Now we're going to move on to understanding and applying similar figures, the angle-angle similarity criterion. So to start this, I want you to look at row A and row B, and you're going to identify the figures that seem similar within group A and similar within group B, and then explain why. And when you're done with that, you can resume the video to watch your answers. So go ahead and do row A and B, and then we'll kind of summarize the bubble together. Okay, so now you've tried that and you've resumed the video to watch the answer. And the first one, it should be figures B and figures E that are similar. So figures B and E are similar. And that's because they have the same square shape, but are not the same size. Okay, so that's row A. In row B, we would say figures C and E. Okay, so figures C and E are similar. And this is because they have the same shape, which in this case is an equilateral triangle, which means all sides are the same, okay? But they are not the same size. So, how did you determine that these figures were similar? The shapes are the same, but not the same size. Okay? So that's basically what we did with dilation. It stayed the same shape. Shape was preserved. Angle measure was preserved, but the side lengths became proportionally larger or proportionally smaller. And remember, when that happens, that's called being similar. Sides are proportional, angles are the same. It's congruent when everything is the same. Okay? So now we move on to angle-angle criterion, which is why this works. Given the information provided, is triangle ABC congruent to triangle DEF? So the only thing that I see given in this triangle is one angle. Well, I have no idea how big this one is and no idea how big this one is, and same for this. So the problem with that is that the triangle has 180 degrees and I only know what 39 of them are doing. The other two can be split in any which way they want. So right now, we don't have enough information. So we are going to write that. We don't know right now because we don't have enough information. All I can say is that they appear to be similar. Like we did on the front, just for our little quick activity. Looking at them, they look like they're the same shape, but different sizes. So that would mean a dilation happened and they must be similar. But I have to be able to prove that. So what if we translate triangle ABC so that angle A equals angle D? So basically I took the little guy and put it in the big one. And it looks like this new picture down here. So this angle up here now, they share, and we know it's 39 degrees. Okay. And now they're also telling me that EF is parallel to BC. So what I'm going to do right now is I'm going to extend these so they look like the parallel lines we're used to. Then our picture would look like the diagram below, which you can see. This one's not exactly straight there. I'll try that a little bit better. Like that. Okay. Same with this one. Crooked. Okay. And it says, can we tell if the triangles are similar now? Hint, think back to parallel lines. So as soon as I make these parallel lines, if I turn my paper like this, I hope you see that we have one transversal right here. And you know what? I'll use a highlighter for the other one. So here's one transversal running like that across parallel lines. And then here's the other transversal running across for parallel lines on the other one. So because those lines are parallel, we can start using what we know about angle relationships from our previous chapter to help us get some other angles. Okay, so these parallel lines are going to create our corresponding angles. And now, because of these parallel lines, we can start figuring out some of the other angles that we have going on. Okay, so the first thing I'm going to notice here is that this angle right here would now be congruent to this angle right here because they are corresponding angles. So angle DEF is corresponding to angle ABC. So they are congruent. Okay, so you might see something like angle DEF is congruent to angle ABC in our notation. Okay, so now I know that those are the same. I already knew the top angle was the same because they're both 39. Okay, and then similarly, if I look over here, I've got this angle that would be the same size as that angle because of the same reason. So angle DFE is corresponding to angle ACB, so they are congruent. So in other words, angle DFE is congruent to angle ACB. So now I have enough information to say whether they're similar or not. And let's go back up here for a second. I didn't point out that this is the symbol for similar. So congruent is the equal sign with that over it. Similar is just the squiggle. Okay, so if I come back down here, now can we tell that they're similar? Yes, now we have the information because we know to be similar, a dilation must have occurred. So if that happened, that means you have to have all the same angles and then your corresponding sides would be proportional. Okay, but we just have to figure out the angles and then we're all set. So triangle ABC is similar to triangle DEF because corresponding angles of the triangles are congruent. So when I say corresponding, that means the ones that match up to each other, not the corresponding angles that we were referring to figure out the with the parallel lines. Okay, so what do we need to know about all three angles? Okay, all three corresponding angles are congruent. We need to know that. Does this mean the two triangles are similar? Yes. So all you have to do is make sure that you know all three angles of one triangle are congruent to all three angles of the other triangle. And as long as that happens, those triangles are similar. That is what's called the angle-angle similarity criterion. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Because if two of them match up, then the third one has to, because of the fact they all add up to 180. And then you're figuring out that they're similar because of that. So at this time, I'd like you to pause the video and you are going to try the practice questions. It says, examine the following pairs of triangles, determine if the triangles are similar, and justify your answer. So at this time, pause the video and resume to watch the results. Okay, in example 1, pair 1 is saying, is triangle ABC congruent to triangle DEF? So I don't even have to go any further. I have the two angles that I need to use angle criterion. So I can right away say yes, they are similar because two pairs of the angles are congruent. Okay, as long as I have two pairs, these by default have to end up being equal to each other because they add up to 180. In pair number 2, is triangle EFG similar to triangle LMN? So here, it looks like they have one pair that's the same, but one pair that isn't. So in this case, we're going to have to find the missing angle in each one of these to see if we have two pairs that are congruent. So over here, we've got 102 and 30, making up 132. So I will subtract that from 180 and see that that would be 48 degrees. So this angle is 48. And over here, I'm going to do 102 and 48 and see that I've got 150. And then 180, take away that 150, would give me 30. And so now I see that I have actually all three angle pairs I can say, or I can just mention the two. So I'll say here, yes, it's similar because all three angle pairs are congruent. So if you have to do the work to find the third one, you can say it's all three, but again, you only really need to know two, which you would do once you find at least one of them in one of the triangles. So if I had just stopped here and not found the 30, these two pairs would have been enough to determine that they were similar. Okay, pair number 3, triangle ABC is triangle ABC similar to triangle FED? So again, I'm going to have to find out some extra angles to see what's going on over here. So 81 and 60 is going to give me 141. So then if I do 180, subtract 141, I get 39. So this one's 39 degrees. And over here, I've got 40 and 81, which would give me 121. And if I take that away from 180, I end up with 59 degrees. So looking at that, I only have one pair that's the same, the 81. So these are not similar. So no, not similar, because only one pair of angles is congruent. So those are not similar triangles. Okay, pair number 4. Okay, you got to take a look at this and see about their angles. So we know this angle is congruent because they each have one arc mark, so we know that they're the same. Okay, and then other than that, these are creating two right triangles. If I were to resketch these are right angles. The person's standing straight up, the tree is standing straight up. So that's the other angle pair that we know that's the same. Okay, so we know, yes, it's similar. And that's because angle, let's see here, PBC is congruent to angle, and we want to make sure we keep them in the right order. P would correspond to Q, so that would go first. B goes to B, and C would go to A, so QBA. And we know that because of the arc marks. And then we know that angle PCB is congruent to angle QAB, because both are right angles. So we have two pairs of congruent angles. Okay, and that concludes your lesson on the angle-angle similarity criterion.